section 4.4 in your textbook, if you're a real stickler for checking off the lessons and what's what. So lesson 4.4 is about factoring. So if you need more reference on factoring, I promised some people in an earlier class I'll post a little video on how I factor if you guys want to look at it. Otherwise, you can look in the textbook and see the notes there on factoring, and we just did the activity in here to factor. Okay, and you can come into tutorial and get help. All right. Then section 4.5 is looking at the quadratics and how we can kind of analyze them and use the factors to help us get more information about the quadratic, not just this yay, I'm factoring kind of idea, right? So a most straightforward question that they're going to ask you, and this is something you would see on a CST or something, very straightforward. What are the solutions of the quadratic that? Okay? And your job is to solve the quadratic. And we're going to learn later that we have more than one option, okay? One option is we could graph this, right? And we could have the calculator find the x-intercepts for us. Another option is we could ourselves look for the zeros, okay? Now, the zeros mean what is becoming 0, x or y? Y. The y coordinate is 0 for your solutions. Think about it. They're on the x-axis, right? They're the x-intercepts. So what we want to do is we want to get everything on our equation on one side of the equation so we can see what it looks like set equal to 0. Or as if, we got all the terms on one side and set the y equal to 0. So I'm going to subtract x and add 4 so that on the right side of my equation over here, I have 0. And then I'm going to do the same things in the appropriate spot on the left side. Oops, I wrote 10 squared, and I should have written 10x squared. Sorry for those of you that were come on, Miss. All right. Now, we're going to factor. Now, all of you have different ways of factoring. Okay. I like to just guess and check, and that means for the 10, I could try 10 and 1 or 2 and 5 as different combinations of factors that could make that happen. And for 42, there's a lot. 42 and 1, 2 and 21, 3 and 14, thanks. And then 6 and 7. Okay. All right, so anybody have a combination they want to try? 6 and 7? Sounds like, don't try any of those other ones. Let's try 21 and 2. All right. Well, what about for the 10? 10 and 1? Or? So you guys want 10 and 1. And you want to try 21 and 2 with that? 21 and 2. Okay, now you guys could have tried a bunch of different combinations before you came up with this one. And my advice would be if you do it this way but you always have trouble, be really methodical about it. You pick a pair, you set them down, you try every combination of those in each different order. Don't cross it out until you've tried all that, and then move on to the next one. Now, he's right here. I see the 10x squared, and I see where the 42 is going to come from. Then I can see here that this would create 21x, and this would create 20x. And when those like terms were added together, if they're the same sign, they're going to create 41 in the middle. And if they're different signs, they're going to create 1 in the middle. And that's what I was trying to get was a 1, a positive 1 specifically. So I'd want this one to be positive and this one to be negative. So plus here and minus there. That makes the 42 negative, which is what I had in my equation. So that all seems to work well. Okay. So that's what you were just practicing. Okay. But our point of this is to set these equal to 0. So let's say I walked in here today and I said, I'm thinking of a number, 2 numbers. When you multiply them together, you get 2. Anybody want to guess what my 2 numbers are? 1 and 2? No. Yes, I'm thinking of 2 numbers, and when you multiply them together, you get 2. What are my 2 numbers? And I said they're not 2 and 1. No. 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 But do you guys see all the guesses that are coming in? How many guesses could you make to that combination of numbers multiplying together to get 2? Infinitely many, right? Do you really know anything about my numbers just because I say they multiply to make 2? No. You know nothing about any individual number. Okay? They're not 0. So here's the cool thing about 0 itself. If I played that game with you again and I said, I'm thinking of 2 numbers, when you multiply them together, you get 0. What do you know about the numbers that I'm thinking of? At least one of them has to be 0. So this whole factoring thing, you should never really do it unless you have 0 over here, because 2 things multiplying together to equal a number tell you nothing really about the two things multiplying together. But two things multiplying together to equal the number 0 tell you that the only way that can happen is if one of these itself is 0. So either 10x plus 21 has to equal 0, or x minus 2 has to equal 0. And there's two x values that can make that happen. One x value that makes this first factor equal to 0, and one x value that makes the second factor equal to 0. So either x can equal 2, or x can equal negative 21 over 10. If you plug either of those x values into the original equation, or into this factored form I have right here, it's going to make one of these factors equal to 0. Doesn't really matter what the other one is, because once you multiply it all out, you're going to get 0. So factoring helps us solve specifically only when we have it set equal to 0, because one, numerically, no other number has the properties that 0 has. And two, graphically, we are looking for x-intercepts, which should be on the x-axis and have a y-coordinate of 0. Okay? So we shouldn't be factoring with something else over here and trying to set that equal. That doesn't work. Okay? So these are our two solutions to this problem. Okay? Any questions about that? All right. So let's look at a more interesting problem. Number 2 is like the same. Example 2 on your note guide is very similar to example 1. So we're going to skip to example 3. So example 3 says there is a function, and they actually give us the equation. We didn't have to go on our calculator or find it or anything like that. Okay? That models the path of a baseball. F of x gives the height of the ball, and x gives the distance from where it is hit. So the ball is hit. X tells us how far away from the person that hit it or where it was originally hit. And f of x, or like the y value, tells us the height of the ball. So the question says, how far does the ball travel before hitting the ground? So before we get into how we're going to do this problem, what are you trying to find, and what information is it giving you by asking you the question, how far does the ball travel before it hits the ground? Okay. Okay, that we're looking for the x-intercept? Is that what you said? So the 0 or the x-intercept, right. So the ball is hit, right? So I don't know, something happens like this, right? Some ball is hit. And it's asking us how far does it go before it hits the ground. So it's asking us to find this x value when we know we're back at the ground, which would be a height of 0. So in our equation, it means I know that 0 is the f of x, or the y value. And I'm looking then to solve this equation for x. So then most people right now would be like, get your calculator, right? Okay. And we're going to use it for some arithmetic stuff. But we can actually solve this quadratic without having to graph it in the calculator and have the calculator find the x-intercept for us. Okay? Now that we've seen what we've seen today, we can actually factor to solve this equation. Okay? How would we factor this? Look at it carefully. Look at what's on the right side. The 0 is good to go. We want it set equal to 0. How would we factor the right side of this equation? Versa? Good. So first we would take out the greatest common factor of what's there, which is x. Okay. And then using what we just talked about here, we have two factors. One factor is just x, and one factor has all this decimal stuff in it, and they're multiplying together to make 0, which means the 0 is only going to happen if the first factor is set equal to 0, or the second and much more complicated factor is set equal to 0. Right, so then we just have to do a little arithmetic, and this is where I said I would be okay with you using your calculator. I'm not totally crazy. I want you to do all this arithmetic by hand. But I wanted you to realize that you have enough knowledge at this point to solve quadratics without your calculator doing like all the calculating the x-intercept by itself. Okay? And you can find the x-intercept this way. All right? So x comes out to be 385 feet. So this represents at a distance 385 feet away from where the ball was hit, it will hit the ground. For how high does the ball go, we would be looking for kind of this maximum height that it reaches, which we know is the vertex. So in order to find the vertex, since we have our 0, 0 point and our 0 at 385, we would find the number that's halfway between 0 and 385, which is 192.5. Now that's the x-coordinate, so that tells me at a distance of 192.5 feet from the thrower, it reaches its maximum height. But their question was, how high does it go? So then what I need to do is I need to take that 192.5, and I need to plug it into the equation I was given that models the motion to tell me what the y value is, or what the height is, at that distance from the thrower. So I'm going to make sure I use 192.5 in place of all of the x values. Okay, and then we're going to go ahead and finish this calculation. So looking at this, 192.5 squared. We get a height, sorry, I shouldn't put it right there. We get that our y value in this situation would equal 74.1125, or that it reaches a height of approximately 74.1, and I'm assuming it's feet, though it didn't say the vertical height in this problem. Then lastly, it asks for a reasonable domain and range of such a function. Now, if I went back up to the graph,